Hey guys, my name is Ethan, this is Carberra. Welcome to the series where I teach you how to code in Python. Today we're going to talk about indexes and slices. In Python they are very interesting. You can employ some very cool syntaxes with this sort of thing. We're just going to be talking about how to index all sorts of different collection types because it pretty much works the same for them all. So once you know one, you can do at least the built-in ones. There are others like NumPy, ND arrays, and pandas data frames that have their own special syntaxes for indexing. We're not going to be talking about that in this video. We're just going to be talking about the base types. So we're going to define a list. We're going to define a list of names. And we're going to do Andrea, James, let's see, Connor, Sarah, and if I could actually type, and God, I don't know, Roger or Rioja. I don't know. Those are just the first names that came into my head. Don't ask me why. Yeah, this is a list of names. And before we talk about how to actually index and slice lists, I want to talk about indexing in Python because it works about the same as it must be at least 95% of the languages out there. Lua and MATLAB are probably the most prominent exceptions to this rule, but collections in Python are zero indexed. So Andrea, despite the fact that it's the first item in the list, is actually element 0. And that's an important one to remember because it can be confusing for people who are obviously used to counting for 1. Typically, computers count from 0. It's just easier for them to do. So this is element number 0. This is element number 1. This is element number 2, and so on. So if I was to print names 0, we would get Andrea printed because Andrea is the 0th element. If we were to do 1, we'd get James printed. So this is how you index lists, by the way. You simply just have the name of the variable, and you open some square brackets, or just brackets if you're in America, and you have a number of the index in there. Obviously, this number needs to be in the range of the list. If you put something that's out of the range, for example 6, you'll get an index error saying list index out of range. One of the interesting things that Python does is that you can actually provide a negative index. So -1 will get the last element in an array. If you type in a negative number, it will actually go backwards through the list and work it out from there. So this is element -1, this is element -2, element -3, etc. If you do -0, it is still 0. And so Andrea is still the first one to be selected. So it's 0 index in from left to right, and 1 index from right to left. Hopefully that's not too confusing. I've literally only just realized that, which is very interesting indeed. But that is the basics of indexing. So now I'm going to talk about slicing. Now, slicing a list is essentially getting a set of numbers. So if I just kind of show you real quick. So if I have names up to 3, we'll see that we have Andrea, James, and Connor. So what this is saying is it's saying get all names up to, but not including index number 3. So we get index 0, index 1, index 2. We don't get index 3 because we don't include it. And then it prints out a new list. This creates a new list with these 3 elements in it. We can also do 4 to get 4 things. We could do -2 to get all of them except the final 2. So it does them all up until the second to last one, which is Sarah. You can do this the other way around as well. So you can start from 3, and this will get all values from index 3 onwards, so Sarah and Roger. You can have 1 and 4, and this will get elements from index 1 up until index number 3. It won't include index number 4 because of course it stops there. So you can get pretty fancy with this. With slicing, you're far less likely to run into errors. If you do an invalid slice, so say 9 and 12, then you get just an empty list. It doesn't throw up an index error like it would if you were just indexing it normally. If you do 9 and 6, it also won't error either. I think if you do like 3 and 2, it will give you an empty list as well, yeah, because you're going backwards, because you're saying get all of them after and including index number 3 up until index number 2, which is back here. So it just works out that it can't do it. However, if you did want to do that, then you could specify a step. Now this is a third argument that you can provide, and we can give this -1. And as you can see, well, actually, let's do this real quick. And as you can see, it's now going backwards through the list. So having this -1 will take us backwards through. So it's saying start at element number 3 and go backwards in increments of 1, and can continue on until you get to index number 1, but don't include that one. So this step, this doesn't have to be a negative number. It can be okay, let's actually do something that's going to work. Let's do 5 and 1. Okay, there we go. It can be another number. So this is in stepping 2. So we're going forwards through the list. Actually, let's start list from the start. Actually, that might be easier. So it's now getting every second element up to and not including index 5, which doesn't exist. But we have Andrea, Connor, and Roger because they are even numbered indexes. Essentially, they are 2 apart from each other. We're stepping across in 2. Of course, we can do this, and we can do this as well. And as you can see, the syntax starts getting a little bit more complicated now. So we have just 2 commas straight up. If you don't pass anything here, you don't have to put in a 0 or anything like that. It will just be able to work it out. And that leads to the interesting syntax of reversing a list. Now you can use the reverse built-in, or you can do this, and this will just work. So you can see it's saying go from the start to the end, just take absolutely everything, and then iterate them through backwards, element 1 at a time. So you then get Roger, Sarah, Connor, James, and Andrea, and all that stuff. And yeah, the syntax does get kind of complicated. You see what I mean about it looks hard, but once you actually understand it, it's quite easy. You can't get a 4th element. That will just kind of break. There isn't a 4th element to pass in. It actually just gives us a straight syntax error if we try and do that. So that's sort of it for slicing indexing. However, there is one more thing that I do want to talk about, and that is how to create a new collection of something. So we can do names2 equals names, and then we can do this. And if we print names2, we'll see that it just created a copy of the first list. So we could do names2.append Tyler, for example, or typer. His name is Tyler the Typer. And if we do print names, don't know what that was. As you can see, we have the names and then we have the second names. And it's a different thing because it created a new list. It hasn't done it in place. If you were to do this, then it would actually add it to them both. Because we're taking the reference here. But this is essentially, whoopsie, that's not what I wanted to do at all. This is essentially just saying copy it. Now this is especially useful in loops and stuff where you need to create a new collection if you're going to be, say, altering the data and it breaks it. Sometimes altering the length of a list doesn't actually affect the iteration. I'm not entirely sure what causes that because it's only something I've noticed recently that actually happens. But if that does happen to you when you get some sort of error saying that you can't edit length of the database or whatever, then you can just use this, or the collection. Again, we've been doing too much data science recently. And then you can just use this to create a copy of it. And then you can just iterate through that instead. And then you can update the original list. And then the first list will get deleted because it's no longer in the scope. So it's just a really nice way of doing that, really. But that's pretty much everything I want to talk about indexing and slicing. Obviously, there are more complicated things, so once you get to like NumPy and stuff, as I said at the start. However, this is just the basics of actually how to do this, and this is pretty much all you need to know for a good amount of time. You can employ this on lists, tuples, and sets. You can also do it on strings as well. So if you want to find a palindrome of a string, all you've got to do is type string and it will tell you what it is. It's kind of nuts how you could just do palindromes on one line, but that's pretty fun. Yeah, if you have any questions, then feel free to leave a comment, or you can join Discord server using the link in the description. While you're down there, I have all my socials down there, so feel free to check them out should you want to. But yeah, that's gonna do for this video. If you liked it, say hello down below. If you really liked it, consider subscribing and hitting the notification bell so you don't miss out on future uploads. And if you really liked it, then consider supporting on Patreon. Of course, you don't have to, but a really cool thing of you to do. With that in mind, I'd like to thank my awesome patrons being awesome, and I will see you in the next video where we talk about defining functions. So this is going to be a really important one coming up next. So I'll see you for that.